All right, welcome to Chapter 3, Lesson 5. We're going to be working on solving equations with a variable on each side. So, kind of the basics of what we're going to learn in today's lesson is we're going to learn how to solve equations with a variable on each side, and we're going to learn how to solve equations involving grouping symbols, such as parentheses. So, one vocabulary term that you want to keep in mind is an identity. So, we'll talk about that a little bit later on in the lesson. So we're going to talk about, well, what does it mean if variables are on each side? Well, many equations contain variables on each side. And to solve these types of equations, we can use addition or subtraction properties of equality along with multiplication and division to be able to write equivalent equations that has all the variables on one side. So we're still going to be solving equations by isolating the variable and getting it all by itself. So let's take a look at an example of what that might look like. So in this example, we're going to solve an equation with a variable on both sides. So it says solve -2 plus 10p equals 8p minus 1, and then check your solution. So again, here you want to notice is I have a variable on the left side of the equal sign and the right side of the equal sign, okay? But just like before, I'm going to start off by just writing the original equation. So here's my original equation. And I'm going to start by trying to get the variable on one side or the other. So I can either get the variable on the left-hand side of the equal sign or the right-hand side of the equal sign. I'm going to start by getting it on the left-hand side. So first of all, I want to get rid of this 8p here. Well, the way that I can get rid of it is I'm going to subtract 8p, because if I have 8p minus 8p, that makes 0. It zeroes itself out. And on this side, I'm going to have 10p minus 8p, which would give me 2p. So I have minus 2p, the plus 10p minus 8p simplifies to plus 2p. On this side, I have 8p minus 8p, which zeroes out, and it leaves me with just minus 1. So I have -2 plus 2p equals -1. So the next step is, again, I'm going to get the p all by itself. So I'm going to start by getting rid of the subtracting 2 or -2 there. And I'm going to do that by adding 2, because I know -2 plus 2 will zero itself out. So that's going to leave me with 2p equals 1, because -1 plus 2 gives me +1. And the final step here to get p by itself is I'm going to divide both sides by 2, because again, the opposite of multiplying by 2 is dividing by 2. So when I divide both sides by 2, that gives me p equals 1 over 2, or 1/2, or 0.5. Typically, it'll specify how it wants the answer to be. Most often than not, you'll see it written as a fraction. And so kind of my rule of thumb is if the problem contains fractions, your answer should be in a fraction. If your problem contains decimals, it should be in the form of a decimal. But since ours started with all whole numbers and it didn't specify, you could put it in either form and it'd be just fine. But obviously, these are all equivalent. So the final part is it's asked us to check our solution. So again, we're going to check it by putting it back in the original equation. And if we say p equals 1/2, then anywhere there's a p, I'm going to substitute 1/2 into its place. So right here, I put 1/2, 1/2, or 0.5. And then I'm going to go ahead and simplify it and see if it actually works out. So I'm going to start by doing 10 times 0.5, which is 5, 8 times 0.5, which is 4. And then -2 plus 5 would give me 3, and 4 minus 1 also gives me 3. So both sides of the equation check out. So my solution is 1/2. That actually does work. So grouping symbols. So sometimes we're going to be working with equations that contain grouping symbols. And so like parentheses, right? And so when we do encounter problems like that, we want to use the distributive property to remove those grouping symbols. So let's take a look at an example. So this problem says solve 4 times quantity 2r minus 8 equals 1/7 times quantity 49r plus 70, and then check our solution. So here we have a set of parentheses on the left-hand side, and we have a set of parentheses on the right-hand side. So we're going to use a distributive property to help us in this problem. So again, here's my original equation. So I'm going to start by distributing the 4 into everything in this parentheses, and the 1/7 I'm going to multiply into everything in this parentheses. So that would give me 4 times 2r is 8r, 4 times 8 is 32, 1/7 times 49r is 7r, and 1/7 times 70 is 10. Now, I want to get the variable on one side because right now it's on the left side of the equal sign and the right side of the equal sign. So I'm going to start by getting rid of the 7r, and I'm going to subtract 7r from both sides. because I know 7r minus 7r will zero out, and it leaves me with just positive 10. 8r minus 7r leaves me with 1r. So I would write it as r minus 32 equals 10. A question that I get asked a lot is, what happens if I put 1r? You can put 1r. 1r and r mean the same thing. But typically you will just see it written as r. And then the final step is to add 32 to both sides. And again, when you have minus 32 plus 32, that makes 0. And it leaves me with just the r. And on the right-hand side, I would have 10 plus 32, which is 42. So here my solution would tell me that I have r equals 42. So now I want to check it. And I'm going to check it by putting my solution back in for r into the original equation. So I'm going to substitute 42 in for r in both places. So again, replace it here and here. 2 times 42, 49 times 42. 2 times 42 is 84. 49 times 42 is 2058. And now I'm just going to go ahead and simplify each side. So here I'm going to start off by doing what's in the parentheses. 84 minus 8 gives me 76. And 258 plus 70 gives me 2128. And then the last part is multiplying. 4 times 76 is 304. 1/7 times 2128 is 304. Both sides check out. It does, in fact, prove that the solution is 42. So this solution was correct. It checks out. So some equations that have variables on each side have no solution. This means that there's actually no value that the variable can have that will make the equation true. And that might sound kind of funny, but let's take a look at it. So here's an example that would have a no solution. So here it says solve 2m plus 5 equals 5 times m minus 7 minus 3m. So here I have a set of parentheses. So I would start out just like the other problems by using the distributive property. 5 times m, and then 5 times negative 7, right? So that would give me 5n minus 35. I still have the minus 3m here, 2m plus 5 on the other side. So now I have 5m here minus 3m. I can simplify that. 5m minus 3m is 2m. So here's my 2m. So I have 2m plus 5 equals 2m minus 35. Now I would want to get the variable all on one side, so I'm going to start off by getting rid of this 2m here by subtracting 2m. Now you might notice something. Here I have 2m minus 2m, which makes 0. Here I have 2m minus 2m, which also makes 0. So those zero each other out. It leaves me with 5 equals negative 35. And if you notice, that is a false statement. 5 clearly does not equal negative 35. So therefore, in this problem, this equation has no solution. There is no value for m that would ever make this a true statement. So this would be an example of a problem that has no solution. So again, you know this when you get two sides that are in fact false, not equal. Now on the flip side of that, there are equations that are true for every value of a variable. So no matter what the value of the variable is, it's always true, has an infinite number of solutions. This is called an identity. So here's an example of what that might look like. So here it says solve 3 times r plus 1 quantity minus 5 equals 3r minus 2. So again, here's my parentheses there. So I'm going to start off by using the distributive property. 3 times r, 3 times 1 gives me 3r plus 3 minus 5 equals 3r minus 2. So now, here I can simplify plus 3 minus 5 makes minus 2. Now if you notice, 3r minus 2 equals 3r minus 2, right? If you notice, that is identical. The left side of the equal sign and the right side of the equal sign are identical. This is what's known as an identity, because if I were to put in any value for r, both sides of the equation will always be equal. Always, right? So just, oops. There we go. So it's something to keep in mind is you might run into some problems. They aren't very common, but they do happen, where you will get two identical sides that are equal and will always be equal for that value. Okay. Since the expression on each side of the equations are the same, the equation is an identity. So the statement, right, the original problem, 3 times r plus 1 minus 5 equals 3r minus 2 is true for all values of r. Um, so let's look at the key concept here to wrap it up. So some steps for solving equations. You have step one, use a distributive property to remove any grouping symbols like parentheses. Step two, simplify the expressions on each side of the equal signs. Step three, use addition or subtraction properties of equality to get the variable on one side of the equal sign or the other. It doesn't matter which side, okay? But you want to get it all on one side. And then simplify the expression on each side of the equal sign. So again, if there's anything to simplify, right? If two values can be added or subtracted together, or uh, two terms with variables can be simplified. And then step five, use the multiplication or division property of equality to finish solving it. And here are your two notes for the two possibilities. Every once in a while, you might get a problem that gives you a false statement, which means there's no solution. And then, or maybe you get an identity, which means that the solution is all real numbers. There are an infinite number of solutions because it's all the numbers, okay? And that is how you solve equations with variables on each side. Thank you for watching. I'll see you guys next time.